Enough about me. This isn't about me. This is about you guys. So basically, it's a bent propeller. If you took this and straightened it out, it'd be very similar to a propeller. And the airplane analogy that I'll use here is that a propeller creates lift because of its design, and then the wings, they also create lift because of the way that they're designed. I'm going to show you a picture of a wing here in just a minute, or an airfoil. So the propeller is just an airfoil, and let me go back to this picture right here. You can see, and I hope that you guys can see my cursor there moving on the screen. This would be the trailing edge. It's kind of a sharper edge, and this would be the leading edge of the other side. It's more rounded and blunt. And then this is a sharper edge back here in the back. So the leading edges, some things say that they're on the same side. I say that they're on opposite sides. If you consider the middle of the boomerang as they call it the elbow, and if you straightened it out, they would be one, and you're looking at the boomerang from the top. Let me go back to my picture here. So this would be a leading edge on this side, and this would be a leading edge on this side. So they're actually on opposite sides of the boomerang. One's on the front, one's on the back. But when this thing is rotating, they're both facing the way that it's rotating. I see you showing a picture there. Can I see that picture?
I'm using my iPad video.
Okay. Sorry, I thought you were showing them a picture. I was like, okay, she's giving them a close-up.
But we are passing around I do have a wooden boomerang to...
oh, fantastic.
Yeah, as display, and we're passing that around as well.
Okay, so you guys can see on that boomerang that you're passing around there, that one side of it, on either side of the elbow, the front edge of one side is more rounded, and the back side of the other, man, this is really hard to do without being there and holding that boomerang in my hand. So the back side of the opposite side of the boomerang is more rounded. So, okay, let's move on. So the leading edges are on opposite sides, and then the trailing edges are also on opposite sides. But they're on the same side as it rotates. So as this thing is spinning through the air, or as it's rotating, you have a leading edge leading or going into the path of rotation, and then you have the trailing edge following that. And then here's a nice picture. There's the elbow right there, so you have this leading edge and this leading edge. So as this thing rotates clockwise, you can see that this leading edge would be going into the rotation, and this leading edge would be going into the rotation. One of the things, and I can't remember exactly what I put on the quiz, but do you see the center of gravity is actually not part of the boomerang? So this is the point about which this boomerang rotates. And I won't get into deep physics here, but the center of gravity of an object does not have to be part of the object. It doesn't have to exist within the object.
So
it's just an imaginary point where if you took all of the mass of the object and squeezed it down to a point, that's where it would exist. Does that kind of make sense? Sort of?
Yeah.
So every object creates its own centrifugal force because of its mass?
Yeah, and we're not really talking about forces at all. We may talk a little bit about forces, but in this case, just center of gravity. It's just a point, sometimes an imaginary, well, it is an imaginary point all the time, because you have to imagine that all of the mass of that object is focused on that one point, if that kind of makes sense. And this is a right-handed boomerang. I think one of the questions was, are there left-handed or right-handed or both? And there are both left-handed and right-handed. And probably the important thing, as you're looking at this boomerang from the top, this being the leading edge and this being the leading edge, if you had a left-handed boomerang those would be flipped the other way. So this would be a leading edge, and this would be a leading edge. So a left-handed boomerang, I think, if I understand this correctly, would rotate in the opposite direction. A right-handed boomerang is going to rotate counterclockwise, and a left-handed boomerang would rotate clockwise, which is kind of interesting to think about, to me anyway. Okay, so we've talked about an airfoil, and these are the parts of an airfoil: the leading edge, the trailing edge, and actually the shape of this wing. If we could look at a cross-section, and I'll go back to my first slide here. Look at the cross-section here, the way that this is designed. This is more rounded on top, and we're looking at the front, so we can't see that it rounds away from us. But the bottom edge is flat. So let me get over to my airfoil shape. So airfoils are very special in the way that they're shaped, and they create lift through Bernoulli's principle, and I'm going to show you a diagram, and then I'll kind of explain that. But the shape of the object is important, and you can actually make an airfoil out of just about anything. Have you guys seen a shape of an airfoil before, or a wing? We can call it a wing if you guys are more comfortable with that.
Yes.
With that word, doesn't matter, but the correct, technically, the correct thing is airfoil. So you can see that this is flat on the bottom, and then it's rounded on the top. Now, here's the important thing about an airfoil and how Bernoulli's principle works. Bernoulli's principle basically says that if you speed up the velocity of air, then you lower the pressure. So just by forcing air, so let's imagine a molecule of air right here and a molecule of air right here. One's going to pass underneath the wing, one's going to pass above the wing. They're both going to reach the back of the wing at the same time. So they're both going to get here at the same time. But because this one on the bottom traveled a shorter distance than this one on the top, this one moved faster. Well, when you increase the velocity, by Bernoulli's principle, when you increase the velocity of any kind of liquid, they call it a viscous liquid, which can be air, it can be water, it can be motor oil, it doesn't matter. When you increase the velocity of it, you lower the pressure. So having a lower pressure up here creates lift, and so the pressure exerted by the bottom of the wing simply pushes it up. And now this is the point. Go ahead.
And the pressure is measured by the viscosity level?
Well, not necessarily. The viscosity is independent of that. Viscosity is a physical characteristic of the liquid.
Yes.
The pressure would be measured by, well, it'd be measured in atmospheres, but we're going to change that pressure if we speed up. If we speed up the air, we're going to change the pressure of the air. Or, sorry, if we change the velocity of the air, we're going to change the pressure of the air.
Okay.
And they're inversely proportional.
Okay.
So higher velocity, lower pressure. Lower velocity, higher pressure. This would be the point if I were in my classroom. You don't happen to have a funnel and a ping pong ball, do you?
No, I don't.
Okay. If you, this would be a good follow-up demonstration. Take a funnel and a ping pong ball.
Okay.
Put the small end of the funnel in your mouth.
Okay.
Put the ping pong ball up inside the funnel, and you, let me unshare my screen, and I'll pretend like I have this, and then you can get hold of a funnel and a ping pong ball and try this. So let me go to unshare my screen here. Okay, so I'm back. So you would take the funnel like this, and put it in your mouth, and put the ping pong ball up inside the funnel, and blow through the funnel, and you let go of the ping pong ball, and it'll actually stay there. And that's because of Bernoulli's principle, because of the shape of the ping pong ball, the air goes around like this, and creates a low pressure on the bottom of the ping pong ball. Sorry, low pressure on the top of the ping pong ball, high pressure on the bottom. It forces the ping pong ball to stay up inside the funnel. So it's something to try. Get funnels and ping pong balls for everybody and let them try it. It'd be fun.
Okay.
So let me go back to screen sharing. Let me pause here for just a second and take time for questions because I've already